You must meet the conditions for the theorem. So you must say f is continuous on the closed and differentiable on the open. How long were you there?
Like 30 seconds.
Oh, thanks, dude. All right.
Hey, Newt.
I don't know anybody else to do it. All right. So, by MVT, there must be a C. I don't actually usually write that on a homework problem, but it technically should be there is a C in 0 to 3 such that f prime at C equals f at 3 minus f at 0 over 3 minus 0. There's got to be a place where the instantaneous rate of change equals the average rate of change. Did you work one side then the other, or pretty much just work both sides at the same time? Both sides. What is f prime at C? 2c plus 1. The instantaneous rate of change at this point C is supposed to be 2 plus c plus 1. I need to know when 2c plus 1 equals the average rate of change, which is 4. And that happens when you solve on 3 halves. Yeah? So that's the place where the tangent slope is like the secant slope between the endpoints. Yeah? All right. What are the three conditions for a Rollet? F is, I'm going to do this in green, F is continuous on the closed. F is differentiable on the open. And the endpoints have to be equal. That should be open. And F at 0, which is sine of 0 is 0, and that's the same as F at pi. Rollet is a special case where the y's are equal so that there's got to be a 0 average rate of change. Therefore, by Rollet, there must be a place such that f prime at C equals 0. You could definitely go f at pi minus f at 0 over pi minus 0. What is f at pi? Or f prime at C, not f at pi. F at C, cosine of C, and cosine of 0 at pi over 2. All right. Does that make sense graphically? Cosine looks like this, yeah? The average slope between the two is 0, and there's a place in the middle where the slope is also 0, and that's pi over 2. That's logical, yeah? Okay. Last but not least, find f prime over f using logarithmic differentiation. If you're like me, you looked at that and thought, huh? What are they talking about f prime over f? But after just mindlessly plowing ahead and saying, I hope it all works out, it did all work out. Didn't you find? Hope you did. So first, what did you do? Took the log of both sides. So the log of f of x on the left is equal to, by log rules, log of x plus log of sine plus log of cosine. Yay? All right. Then, by differentiation, we need to take the derivative. Obviously, the question has find derivatives in it. So if I take the derivative by chain rule, it's 1 over f of x times, hey, that's where that's coming from. Now I see where they're coming from. That's big. All right, so the right side is plus cotangent plus tangent, not sine. What am I talking about? Sine. Okay, tangent. And do I then move over f of x? No, they wanted you to find that. I am done. Yeah? That's what I said, minus tangent. Good job paying attention, partners. All right. So, today's lesson. So I will, where's the notes? There they are. Okay. So, I got to kind of warn you a little bit here, all right? I used to think, oh, this lesson is so easy, and I didn't really even teach it. I said, they'll just kill this, because the ones in the Saxon the book are pretty easy. I mean, there are no word total jokes, but these are actually pretty gotcha on the AP test, and so I'm trying to, in these notes, give you an idea of how hard this can be, so that you're a little better prepared. All right, so I guess I'll warn you, these notes are, some of these are humdingers in the notes, all right? First of all, these are erroneous. Would you scratch these? I don't mean for those to be there. All right. So, let's talk about this being the middle of the notes, not the start. Let's talk about this being the start of the notes. How do you show a function is even? You show that when you put in a negative x, you get out same as positive x. In terms of graphs, the symmetry of an even function is at the y-axis. To demonstrate a function is odd, what do you have to show? When you put in a negative, you get out a opposite result of the normal function, all right? The symmetry of an odd function is at the origin, not the x. How can it not be, why can't it be symmetry at the x-axis? Because then it wouldn't be a function. It says right there it's a function, so okay, it's got to be at the origin. So if it's at the origin, then it has to be one of our two pairs of quadrants. It could either be first, third, or second, fourth. Yay? Okay, but it has to be through the origin. Actually, it doesn't have to be through the origin. Give me an example that's not through the origin. Okay, so something like that. If it's continuous, it's got to go through the origin. But those are all odd functions. Are you down? Okay, this, my friends, this is a CU Calc 1 question. I thought it was nice, a good use of even or odd. So would you try and show or sketch what the graph of that would look like that satisfied all of those conditions? Those 6 conditions. I personally start with the easiest no-brainer stuff. Something else. Talk over. Softest thing to do is start with the point 1, 2, which gives you something else. If it's odd, that means it's also got to pass through -1, -2, yeah? So anytime they give you even or odd, they're actually giving you 2 points instead of 1. 2 for the price of 1. Cool. What did you do after that? Let's draw from 0 to 1. What's the graph going from 0 to 1? Down or increasing or decreasing? Increasing, concave, up. So increasing, concave, up. Do you know it goes through the origin? Why? I just told you not every odd graph has to go through the origin. It could, doesn't have to. This. That's what tells you it goes through the origin. The derivative exists at the origin. So surely it must go through the origin. All right, so concave up. And then what does it do after 1? Decreasing concave up. And so that's decreasing concave up. What else does it do? Did you approach the asymptote here? Yeah? Okay, cool. By symmetry then, if the 0 to 1 region is increasing concave up, then what does it feel like the other side should be? Decreasing concave down. If this part was decreasing concave up, then its reflection should be increasing concave down. And if this is approaching y equals 1, this should approach y equals -1. Now, students feel like, wait a second, you have to approach the same thing on both sides. The answer is no. A horizontal asymptote does not have to apply to both sides. Furthermore, there's a second graph that is possible. It said it doesn't have to be the same on both sides. So, is it possible that it approaches y equals 1 on the right side? Okay, if it did, then wouldn't it go, or sorry, it does approach y equals 1. Is it possible that it approaches y equals 1 on the left side?
Yes.
Okay, in which case, this side would have to go approaching -1. So yeah, there's a second possibility. Who's to say y equals 1 is the right side asymptote? Could be the left side asymptote. What does have to be the case is that those horizontal asymptotes have to be different on either side. Have to be. Okay? So that's a good one. That's fun practice. Let's talk integrals. If f is even, then what do you know about a symmetric integral from negative b to b? It's not 0, it's double 0 to b, yeah? Okay, think of a parabola if you like, or cosine. What do you know about odd in a symmetric integral? 0, that's pretty great. It doesn't matter, you're going to have right, left, or above and below axis area. It's good to go. These are not even or odd ideas. I just felt like this needed a little bit of reviewing. So tell me, how would you say this in plain old English? F is greater than or equal to 0. You got me. Outside of anything. I was thinking non-negative. Okay, but okay, greater than or equal to 0. Cool. If f is greater than or equal to 0, then what do you know about the area under f? Positive. Then this must also be greater than or equal to 0. If the y values of f are always greater than or equal to the y values of g, then what do you know about the area under f? Greater than or equal to the area under g. Cool. And last but not least, this is, I didn't give you enough room to do both of this, but that's okay. Say f is between some lower bound and upper bound. Let me ask you to talk about the area under f. Well, let's develop this slowly, shall we? So if f is between u and L, then the area under each should also hold true. So the area under f should be less than or greater than the area under L and less than the area under u with respect to x. You follow me? Okay? What is the antiderivative of L, which is constant? Lx from A to B. This guy, I don't know. And what is the antiderivative of u with respect to x? Ux from A to B. Okay? So, isn't this then L times b minus a is less than or equal to the integral, or the area under the f curve, which is less than or equal to u times b minus a. Yay? All right. Think graphically also. Would you give me a picture here? Draw an f. And say you had an upper bound that was like this for you, and a lower bound that was like this, L, and it was from A to B, right? So the middle obviously is the area under the green curve. What does this side represent geometrically? The area of that there rectangle. Isn't that a height of L and a base of B minus A? Yeah? All right. And I think you'll agree that the area under F is greater than that blue rectangle. In terms of the other side, the area under U would be something like this. Now my picture's a big mess. But the rectangle there is B minus A wide and U high. And surely the green area, the area under F, has to be less than that. Yeah? So it's less than the two enclosing rectangles. Is that clear? Okay, cool. Now let's practice this. For reasons you will see soon, I'm going to make you show what you feel to be way more work than is necessary. I will explain. Would you, I'm going to have you give these a little go first, and then we'll see how it goes. Would you give, I think I gave you everything you needed. Did I give you everything you needed? You need, sorry, this I was supposed to give you. Would you put a 3 down here? I don't know where that went. Okay. Would you try the first one on your own or with your math amigo? And let's see how you do. Ready? Or not yet? Okay. So your answer for the first one? 3, 6. 3, 6. That is exactly why I will make you show the work. So here's what it should look like. Nobody got the answer right, but I heard it goes like this. First of all, you should see these, and your warning bells should go off. That is dangerous right now. What's the problem? Yeah, if you're going from -5 to -8, you're going left, which means dx is negative. Okay, if you're going from a greater number to a lesser number, you're changing x in a negative way, you're getting opposite area, that's bad. Your warning light should say, whoa, that is terrible. The first thing I should do is say, I want the limits to go left to right. Right? Now, what do you reckon that relates to on the positive side? Is it the same as F? And is it the same as positive 8 to positive 5 or positive 5 to positive 8? Say, imagine, if you would, then help yourself out. Imagine just a plain old parabola. -2 to 0 to 2. Is it the case that -2 to 0 is equal to 0 to 2? Or is it the case that -2 to 0 is equal to 2 to 0? Which one's right? The first one or the second one? The first one is true. Positive and positive, that's true. All right? So first, don't think that, oh, these have to match 2 and 2. Yeah, left to right. Left to right has to be the same, left to right. Okay, so this is the same as the opposite of positive 5 to positive 8. Alright? Now in terms of over here, you'll notice that if you're just throwing around 10s and 4s, that won't do ever for me, especially on a test. Okay, you must communicate integral work. I don't care if you cut a little corner with the argument. If you just wrote F here and no differential, okay, I'll throw you a bone and call that good. But at least you have to have integral arguments for this to hold water with me. All right, so how do you find 8 to 5? You don't have 8 to 5. You have 1 to 8 and 1 to 5. So you could take 1 to 8 and subtract away 1 to 5. So this is the opposite of 10 minus 4. It is negative 6. Negative 6. Okay? Try the second one, please. Try the second one. Ready? Yes, ready, or give you another minute? Another minute. Okay, so your multiple choice answers are 8, 12, 24, and what else might that be? 8, 12, I'll just go 8, 12, and 24. I have to make up a bonus. So what's your answer? 24, good, okay. Most people would choose 12 because they think, well, F is the same as the positive side, so that's 10, add 2, boom, that's 12. Well, you are going way too fast, okay? First, did you split this, or did you just flip this over? Flip it over. Does the 2 affect the even? Doesn't the 2 shift the graph up? Does shifting a graph up affect even or odd? It does not. What did it affect? Does it affect even? No. Does it affect odd? Yes. Okay. So the fact that this is shifted up 2 does not ruin the even. We're good. So did you say this is equivalent to positive 1 to positive 8 on the right-hand side? Yes? Okay. Is this equal to 1 to 8 plus 2, and therefore 10 plus 2? Nope, they didn't integrate the 2. 2 is in the integral. You can't just say, just stick that off to the side, add it. No, it must be integrated. It's the integral of f and the integral of 2. And so that is 10 plus 2x from 1 to 8. You are correct if you said it is 24. All right. And then the last one. Give the last one a go. A little gander, a little what for. are you ready? That's a humdinger, baby. You have an answer. What do you say? Wow, I am impressed. How'd you do it? How'd you do it? Ultraviolet voodoo. Okay, cool. So you said something like U is X and dV is prime, therefore du is dx and v is f, yeah? So, did you keep the limits? Did you play with the function or call it, get into even or odd at this point early, or did you do this first? Okay, so negative 5, sorry. So negative 5 to 5, uv then is x, f of x. I'm going to do an evaluation bar here, negative 5 to 5 minus the integral from negative 5 to 5 v du, so f of x dx. Cool? All right. Now, what did you do then? Did you work put over here? Yes? No? So did you say something like 5f at 5? Times 2? Double 0. Is this equal to double? Like, are you saying this? No? Yes? No? So, you're hoping it works. What are you're claiming it's even? You know it's even? It says f is even, not f prime. And surely not xf prime. Wait, you're just saying, I hope to God it's even. Really? You have no, it might, you're right, it might be. It might not be. Okay, so it feels like you just won the lottery because you have no freaking idea why it's even. You're just okay. So, at work here, this is true, not because you know anything, but just because you lucked out. If f is even, then that implies that f of negative x equals f of x, yeah? All right. So if you take the derivative, f prime of negative x times negative 1 equals f prime of x, yeah? What do you make out of it? That means that the derivative is odd. Okay? F prime is odd. Now, whether you know it or not, you just proved a big theorem of mathematics. The derivative of an even function is odd. And likewise, the derivative of an odd is even. That holds to be true if you look at sine, cosine, tangent, cubes, squares. It's true. Now, that said, it feels like f prime then should be odd. But with the x there, then you're talking, if you put in a negative x times f prime of negative x, then that's the same as negative x times, because f prime is odd, that implies negative f of negative x, which is the same as positive x, f of x, which implies that xf prime is even. Actually, this should have been even. So, yeah, wow, you're lucky. You should buy a lottery ticket on the way home because you're really lucky. It's better to be lucky than good, apparently, because I'm just thinking and thinking and thinking. You just, 14. All right. So, it is the case that this is even, that f prime is even. So if you said this is the same as double from 0 to 5, then that is true. This is true, and that actually makes the rest of it a little easier. This part would be 5 f at 5 minus 0 f at 0. This, I think they give you that, didn't they, somewhere, it's 3 or something like that, is that right? Okay, so this is 2 times, what is that, the 5? 2? Minus 0, minus 3, so 10 minus 3 is 7 times 2 is 1. Okay, that said, that was a humdinger. That was the hardest one I could come up with on my own. Let's go to ones that are more like the book. So, if you would, go to box 10. You don't have to write the problem, but what's given in the book is that f is a function that is odd, that the integral from 0 to 4 is 7. What is the integral from negative 4 to 4? It is 0, because it's odd. There's symmetry, and it's 0. So what do you have to show? You do not have to show anything. 0 is 1. Okay? Yes. Lazy weasels rejoice. Number 11, they give you that g is an even function, and that the integral from negative 4 to 4 is 4. From that, you should be able to conclude that the integral from 0 to 4 is 2. That also you could do without it. Okay? 9 then is a proof. 9, prove that if f and g are odd, that then fg is even. This is just me starting. So how do you prove even or odd? Anytime you are asked to prove even or odd, you say what happens if you put in negative. Okay, so what happens when you put negative x into f times g? That's f times g, not f of g. That's multiplication, not composition. What is that the same as? That notation is a little shortcutty. What should this be written like? F of negative x times g of negative x. Instead of having some kind of one argument, it really should be written that way. All right. Well, then, if you're given the fact that f and g are odd, what does that imply about f of negative x? It's the same as the opposite of normal, f of x, so negative f of x, and I guess we'll break all rules of serious proof, and that is to let you make 2 changes at one time without even saying what you did off to the side, and therefore, you get f of g of x, which proves that when I put in a negative, I got the same as when I get a positive. That is the definition of even. Fg is even. You can prove that when you put in a negative, you get the same as when you put in a positive, then you have proven that it is an even function. All right? Here we go. That's good. Homework. How'd the homework go? Terrible. Not so hot. I have some various slides pasted in here in the order in which they asked questions, but we didn't get to other questions, so we might have to finish this tomorrow. Again, lazy weasels rejoice. So, 7. How did 7 go? I don't know. I don't have the answer.
7 was difficult.
7 was difficult. I have for 7a, I have 23.8105 miles per gallon. Okay. For B, I have negative 5 point, sorry, I said dmdt that is negative 5.9765, which is less than 0, so the gas mileage is decreasing. Shall we talk about one or both of those, or no, they were fine?
Let's talk about both of them.
Okay. All right. So what's the hard part to this problem?
Interpretation.
Okay, I don't feel like it's interpretation. The problem is that mileage doesn't depend on time. It depends on velocity, which in turn depends on time. This is the whole reason that the chain rule was created. When you have a function within a function, or functions are indirectly related. Part A, I feel like should have been doable. How do you find the gas mileage at time 7 minutes, given that mileage isn't a function of time? Yes?
So, I have a different question.
Hit me.
So, if you're
Oh,
Because that's the right answer if you just plug in 7, but you have to plug in 7/6 because it's in miles per hour.
oh boy, good call. Wow, way to go, Marina.
I'm not taking 8 minutes miles per hour.
Yeah. So yeah, I do have a little bit of a units leap in logic for my problem here, yeah? So did you convert,
Just
um,
put 7/6 and plug it in.
did you convert M to,
I just converted 7 minutes to hours. That was easier.
7 minutes to hours? Does that
7/60.
time equals 7 hours? M is in miles per gallon, velocity is in miles per hour. So in this, time has to be in hours, yeah? And I don't even give you units. How do you know that's not minutes? You actually, except there, so you're assuming 7 minutes there. Yeah, you caught me. I did not intend for that to happen. All right, I guess you're right. We're going to have to work out the units. I was just focusing on chain wall, but I didn't even see that the units were different.
If you just convert minutes to hours, it's like 7 minutes to.
Yeah, but this function is based on miles per minute.
No, it's miles per hour.
Oh.
V is in miles per hour.
Oh. I'm with you. Actually, I don't even think I do have an issue then, don't you? So when I plug in time equals 7 minutes into this, what do I get out for V? I don't think I do have an issue, sorry. Okay, so V is in miles per hour already, so I feel like there's no units issue. Okay, so when time 7 minutes is used, I get a V, and that V is in miles per hour, and that's used for miles per gallon. So I think we're good. Okay, now you make me freak out. All right, so do you agree that to get mileage at 7 minutes, I need to know the velocity at 7 minutes, yeah? All right, so I would find the velocity at 7 minutes, which is what did I do here? Oops. Oh, please tell me I didn't lose all these functions. What the heck? Why is this eraser going here? Do-do-do. Jeez, what the freaking heck? Okay. Are my functions in? Yes.
We don't have to go with the first part if you don't need to.
Doggone it. Thank you. Okay. Okay. So, there are 2 ways to go about B, all right? One is in a very classic chain rule-y kind of way, which is to say I could find how mileage is changing with time. That is the question. How is gas mileage changing with time? By first saying, how does mileage change with velocity? And then, how does velocity change with time? That is what the chain rule comes from. Now, the problem with that is that the instants are different, and most students don't like that way. So although I'm going to throw it up there, most students prefer this way. I would most prefer this. If you just make a miles as a function of time equation, isn't miles as a function of time m of v of t? You follow me? All right. Now, assuming this is calculator active, which it is, then the hard part is, and this is the part that I can advise you calculator-wise, there's a smarter way and a grosser way. If you actually try and write one big function of 18 minus 6 cosine of pi, and then you try and type all that in, and then minus 90, parentheses are lost and mistakes are made, and it's a disaster. It tends to go bad. So in terms of calculator use, the most clean way is to first put this in F1, right? And then in F2, you would say F2 is something like 18 minus 6 cosine of pi F1 minus 90 It's much easier to put in with your calculator without error, and it tends to go better. You follow me? Okay. At that point, then, you can have your calculator do all the heavy lifting. M at time of 7 is whatever the derivative of f2 is at time 7. It would be a function of time at that point. And that's where I got my answer, negative 5.9765. In terms of the units, those are miles per, that's m prime. So what are the units on that? It's dm dt. So what are the m units? Miles per gallon over dt, and time units are minutes, all the way back to minutes. Okay? Okay. That one was a disaster, but it was intended to be that. How did this guy go?
First two.
Good, excellent. All right, we're not going to have time to go over this. I think you should know that in terms of checking your work, if you do this geometrically, should it be area of the base times the height? And therefore your area should be, what? 4 by 4 over 2 times 3. Did you get something like 24? Okay, all answers should be the same as 24. So the question is, how did you cross-section it? 12? Did you do left to right? The base isn't the base 4 and the height 4?
Yeah, it is.
And so isn't the area of the triangular cross-section
Would the family please come to the main office?
times the height of
Donald Chu,
3?
Heather Edwards,
I'm pretty sure on 24.
Yeah.
Okay. We'll finish going over tomorrow. We have to.
Wait. Oh, wait, no, I have my schedule. No, not. Oh.
Do I have next? Oh, that's not Jeff? You're not him?
No, I am now. I was going for detective,
Oh.
but I realized it didn't work out so well with the hat.
Wait, Zach, can we talk to John Patty today? Because he's also missing a detective. He knew himself a little bad and everything is super cute. Oh my gosh, you should actually, I have this piece.